In this video, I'm going to talk about factoring polynomials. I'm going to start with number 11. And if you have your factored checklist, pull that out and refer to that. So I'm looking to write this trinomial as a product of binomials. And one of the main ways that we did that in this unit was to do the box method as a way to organize our terms. So 2x squared minus x minus 21 goes across the diagonal. And then we're looking to split up that middle term so that we can factor out some common factors in each row and column. So remember we had to do a times c, so that is 2 times negative 21, so that's negative 42, and I'm looking for factors of negative 42 that add to negative 1 because of this coefficient right here, the middle term, the b value. And you can just do a systematic list: 1 times 42, 2 times 21, 3 times 14, 5 does not go in, or 4 does not go in there, 5 does not go in, but 6 does 7 times. And then once we see that we have consecutive numbers or repeated numbers, as sometimes the case, we know we have all factor pairs. And so now I know that my product needs to be negative, which means one of my factors needs to be negative. And since I want it to add to a negative, I need the bigger one to be negative. And I can see here that 6 plus negative 7 is negative 1. So it does not matter if I put the 6x here or in the upper right corner. I picked it this way, but it comes out the same no matter which way you do that. So I'm looking across the top. What is my greatest common factor here? I have a 2 and a 7. Those are prime, so only an x can divide out here. Across the bottom, I have 6x and 21. 21 is not divisible by 6, but it is divisible by 3, and so is 6. So 3 can divide out. In my left column here, 2 does come out of both 2 and 6, and I have an x. So 2x is going to go here. Now this is a double check. I should know that this is 2x if this is x, because x times 2x is 2x squared. And 2x times 3 is 6x. So far it looks like we're doing this correctly. And in my last column, because this is negative right here, I know I'm going to have a negative out for my factor. And 7 divides out of both 7 and 21, so it's going to be a 7. And there is not an x here, so I cannot divide out an x. But I can do a quick double check here. Negative 7 times x is negative 7x. Negative 7 times positive 3 is negative 21. So my outside numbers multiply to my inside numbers, and that lets me know that these factors are correct. So x plus 3 and 2x minus 7 would be my factors for 11. So this is our answer. Looking at number 12, I do not have a trinomial, but I can think of it as a trinomial, so I can still do the box method. So this would be 4x squared plus 0x minus 25 if it's in standard form. And so I can still think of this in my graphic organizer of a box. 4x squared, 0x in the center, and minus 25 down here. And so when I'm looking for my factors here, I'm looking for factors of 4 times negative 25 or negative 100. And I need them to add to 0. So that means it has to be the same. And that's going to be 10 and negative 10. So 10x and negative 10x before I divide out my greatest common factors of each row in each column. So across the top here, I have 4x squared and negative 10x. And x can come out. 4 does not divide evenly into 10. So I'm going to go smaller, so 2. And 4 divided by 2, and 10 divides by 2. Now I'm going to look at my bottom row. And again, my smaller number does not divide out of 25, but I can go smaller than 10, which would be 5. And 10 divides by 5, and 25 divides evenly by 5. So a 5 is going to divide out. Now I'm looking at my columns. And again, you can do it two ways. 2x times what would give me 4x squared, or I can look here and see that a 2 divides out and an x divides out. This is going to be 2x. And here, again, 10x and 25 is going to be 5. Because of this subtraction, there's going to be a subtraction right here. And so this factors out to be 2x plus 5 and 2x minus 5. And lastly, I want to talk very briefly about 16. When we have a 4-term polynomial, we have all 4 boxes covered. We don't have to figure anything out. There is no middle term. So we start in the upper left with our x cubed, then minus 4x squared, 3x, and minus 12. And we are going to do it the exact same way as we do with a trinomial, except for we didn't have to figure out these 2 boxes. Those were given to us. So across the top, x squared can divide out evenly. Across the bottom, just 3. In my left column here, an x can divide out. And in my right column, a negative 4 can divide out. And so just a quick check that the outside numbers must multiply to the inside numbers. So x squared times x is x cubed. 3 times x is 3x. X squared times negative 4 is negative 4x squared right here. And then for this negative 12, we got that because negative 4 times positive 3 is negative 12. And now we're ready to write our factors. So we would have x minus 4 and x squared plus 3. I'm going to move to the bottom of the page and just talk briefly about these 2 polynomial problems. So we want to add to our notes that perimeter means you add all sides, and area of a rectangle is length times width. So this is a multiply problem. So you would go ahead on this one, 2x plus 4 times 3x plus 6. We want our answer in standard form, so you're going to have to multiply those out like we did in a previous example. So take a moment to do that. As well as for 17, you're going to add these up, and you just need to make sure that you combine your like terms when you add up this plus this plus this plus this. You can only combine like terms.